Standard Wi-Fi was never built for batteries. If you try to run an old ESP8266 or basic Wi-Fi module on a compact battery pack, it will drain your cells in a matter of hours. But this is the NRF7002DK from Nordic Semiconductor, and it completely rewrites the rules for wireless IoT. By combining an advanced dual-core host processor with an ultra-low-power Wi-Fi 6 companion IC, it bridges the gap between high data throughput and battery lifespans measured in years. Today, we are deep diving into the unique dual-chip architecture of this board, exploring its Wi-Fi 6 power-saving physics, and analyzing how it forms the ultimate backbone for the new Matter smart home standard. Part 1. The dual-chip, dual-core architecture. To understand the NRF7002DK, you have to realize it isn't just a single microcontroller. It is a highly strategic dual-chip system. First, we have the host processor, the NRF5340 SoC. The host processor is actually a dual-core beast in its own right. It features a high-performance 128 MHz ARM Cortex-M33 core dedicated entirely to your application code, paired with a completely separate 64 MHz network core, managing the low-power Bluetooth LE, Thread, and Zigbee stack. This powerful host uses a dedicated high-speed QSPI bus to talk directly to the star of the show, the NRF7002 Wi-Fi 6 companion IC. Because the NRF7002 handles the intensive physical layer Wi-Fi tasks independently, it frees up your application processor to stay efficient.
Part 2. Wi-Fi 6 Secrets, TWT and OFDMA. Why choose Wi-Fi 6 for low-power IoT? It comes down to two revolutionary features implemented on this silicon. The first is Target Wake Time, or TWT. In legacy Wi-Fi systems, a device has to remain awake to listen for network traffic constantly. With TWT, the NRF7002 negotiates a hyper-precise wake-up schedule with the Wi-Fi 6 router. The device can sleep peacefully for hours, wake up at an exact millisecond to dump its sensor packet, and instantly shut down its radio, slicing battery consumption by up to 80%. The second secret weapon is OFDMA. In crowded spaces or smart home environments with dozens of components, traditional routers throttle under device interference. OFDMA splits a single channel into multiple subchannels, allowing the NRF7002 to communicate reliably, even in a dense cloud of active electronics. Part 3. The Matter protocol integration. This multi-protocol ecosystem makes the NRF7002DK an absolute powerhouse for the open-source Matter smart home standard. Matter requires a mix of protocols to work seamlessly. When you build a Matter accessory on this board, it uses Bluetooth LE for zero-friction device setup and commissioning. Then, depending on your architecture, it routes lower-speed telemetry over local thread mesh networks, and instantly switches to the NRF7002's dual-band 2.4 and 5 GHz Wi-Fi when high data throughput is required.
Part 4. Prototyping ecosystem and power analysis. For developers, the kit includes an onboard Seger J-Link debugger, meaning you don't need any external hardware to step through your Zephyr RTOS code using the NRF Connect SDK. It also breaks out dedicated current measurement pins. By connecting a power profiler kit directly to these pins, you can monitor exact microamp power signatures in real time as the Wi-Fi radio fires up, ensuring your power budget stays perfectly within a compact LiPo battery curve. The NRF7002DK is a masterclass in professional, enterprise-grade IoT design. Drop a comment below if you want a complete step-by-step coding tutorial inside the NRF Connect SDK environment. Hit subscribe for more embedded deep dives, and I'll catch you on the next project.